Prove that the points A, B, C, and D are in such a way that the line segment AB intersects the line segment CD at the point P. Okay, let us begin. So here we have 4 points. We'll begin by first considering the point A and B. Let's say we have a point A and B, and here we have another point P that lies on the line segment joining A and B. We will first begin by computing the vector AP and then the vector BB. Okay, now AP vector. Now in terms of the position vector, AP vector can be defined as take the position vector of the endpoint of the vector. So that's AP vector, OP vector, where O is the origin, minus OA vector. The OA vector is going to be the position vector of the initial point. Now here we have the point P with coordinates 1, -1, and 2. Now we can convert it to a position vector. All we have to do is multiply the x coordinate with I cap, add it to the product of the y coordinate with the j cap. We have I cap minus j cap, add it to the product of the z coordinate and k cap. So we get 2k cap. And from here, we're going to subtract OA vector since the coordinates of point A are 6, -7, 0. So in terms of the unit vector, it's going to be 6i cap minus 7j cap plus 0. Now, when you simplify this, we're going to get -5i cap. Then we have plus 6j cap plus 2k cap. So this is going to be our vector AB. Similarly, we can find out the vector PB as well. So PB vector in terms of the position vector will be OB vector minus OP vector. So that's going to be equals to, now position vector point B is going to be 16i cap minus 19j cap minus 4k cap. And from here, we're going to subtract the position vector of point P. So that's I cap minus j cap plus 2k cap. Now this is going to be equals to, so we have 15i cap, then we have -18j cap and minus 6k cap. Okay, now let's take -3 as the common factor. So we have -3 times -5i cap plus 6j cap plus 2k cap, which means that PV vector can be also expressed as -3 multiplied to the vector AP. This means that our vector PB is going to be equals to some scalar lambda multiplied to the vector AP, where lambda equals -3. This simply tells us that the points A, P, and B are collinear. They are collinear points. Now next what we'll do, we'll consider the point C and D. So here we have the point C with coordinates 0, 3, -6 and the point D with coordinates 2, -5, 10. We're going to join point C and D with the help of a straight line and consider the same point P lying on the line joining CD. The first what we'll do, we'll find out the vector CP and then we'll find out PD vector. So now CP vector is going to be equals to, in terms of the position vector, that's OP vector minus OC vector. The OP vector is going to be I cap minus j cap plus 2k cap. And from here, we're going to subtract OC vector. The OC vector is going to be 3j cap minus 6k cap. Let's simplify this, and that's going to give us I cap, that's going to minus 4j cap. Then we have 2k cap minus -6k cap, so we're going to get plus 8k cap. And we're going to find out the vector PD. So PD vector is going to be OD vector minus OP vector. OD vector is going to be 2i cap minus 5j cap plus 10k cap. And from here, we're going to subtract OP vector. So that's going to be I cap plus j cap minus 2k cap. That's going to give us I cap minus 4j cap and plus 8k cap. Now this means we have here, we are getting the relationship CP vector equals mu times PD vector, where mu is some scalar with a value equals to 1. Now when this particular criterion is met, this simply tells us that the points C, P, and D, these 3 points are collinear. So here what we have done is that we have considered the points A, B, C, and D, including the point P. They are such that if we consider the set A, P, B and the other set C, P, and D, these two sets are collinear points. And thus means that A, B, and C, D are going to intersect at the point P.